Hi everyone, part 4, surface area of right pyramids and cones. The volume of a right prism is 3 times the volume of a right pyramid with the same base and the same height. Or, the volume of the right pyramid is 1/3 the volume of the right prism with the same base and the same height. Basically, think of it like this. Okay, so here is a right prism. Okay, so if I put a point, an apex, right up there, and I draw, okay, so this would be kind of the right pyramid for that shape. So as you can see, it doesn't take up as much volume. Of course it doesn't. Okay, and it just works out that it is 1/3 the volume of the entire shape. Okay, so the volume of the right pyramid is 1/3 times the area of the base times the height. Okay, awesome. Okay, so example 1, determining the volume of a right square pyramid given its slant height. Okay, so calculate the volume of the right square pyramid to the nearest cubic foot. Okay, so here's the thing. If I want to do this stuff, how that works, so we have a slant height of 7 feet. You can sort of see that dotted line in there. It's kind of tricky. In order to figure out the volume of a pyramid, I need the actual height. So I need to draw right down to there. Okay, and you can sort of see that really thin triangle there. Okay, so the triangle I just drew is this one. Okay, we have a base of 1, because it's half of 2, right? So base of 1. The slant height was 7. So if the slant height is 7, then we're looking for the actual height. Okay, so this is backwards Pythagorean theorem. So that is 7 squared minus 1 squared. So 7 squared minus 1 squared. Well, remember, 1 squared is just 1. So h squared, so 7 squared is 49, minus 1 squared is 1, so that's 48. So then square root, and h equals root 48, which approximates down to 6.9 feet. Okay, so then the volume of this thing, volume is 1/3 times the area of the base. Okay, area of the base is, well, 2 times 2, so 2 feet times 2 feet. Okay, times the height, which is 6.9 feet. Okay, so 2 times 6.9. Okay, we type that into our calculators and we end up with, okay, 9 cubic feet. So Ft cubed. So the volume of this pyramid is 9 cubic feet. Awesome. So we can write algebraic formulas for the volume of a right rectangular prism and a right rectangular pyramid with the same base and the same height. Okay, so remember, a rectangular prism is just a box. So the volume of a box is length times width times height. So remember, I draw the apex there and I draw the pyramid up like that. So this pyramid fits inside the box. Okay, so the volume would be 1/3 of the prism. So 1/3 length times width times height. Okay, these are the formulas that are actually on your formula sheet. The area of the base one is really nice. Okay, but the thing is, we usually use common shapes like rectangles, squares, circles, that kind of stuff. So we don't really need the area of the base part, just use these formulas here. So volume, length times width times height for the prism, and then 1/3 length times width times height for the pyramid. Okay, so example 2, determining the volume of a right rectangular pyramid. Determine the volume of a right rectangular pyramid with base dimensions 3.6 meters by 4.7 meters and a height of 6.9 meters. Answer to the nearest tenth of a cubic meter. See how they just say height here? So that is the actual height of the pyramid, not the slant height. So the real height, that's the one we want for this. So volume of a pyramid is 1/3 length times width times height. So 1/3 times the length, so that would be 3.6 meters, times the width, 4.7 meters, times the height, which is 6.9 meters. So 1/3 of all of that. Okay, so we type that all in, and we end up with, so the nearest tenth was 38.9 cubic feet. So we write FT cubed for that. Awesome. Okay, so remember, the volume of a cylinder and a cone, they're going to be related in exactly the same way. Okay, they have the same bases. So if I draw the apex up to here on the cylinder, okay, we just get the cone. Okay, so that is going to be the same 1/3 ratio. So the cylinder has a volume of pi r squared h. So the cone then will have 1/3 pi r squared h. Okay, again, these ones are on your formula sheet, so perfect. Okay, example 3. Okay, determine the volume of this cone to the nearest cubic millimeter. Okay, so the volume of a cone is 1/3 pi r squared h. Well, that's great. Now, the only trick here is you have to pay attention. This 8 millimeters, that's a diameter. So the radius is only 4 millimeters. So you have to use that one in the formula. So 1/3 pi times 4 squared times 13. Remember, you have to use the pi button on your calculator. Okay, so 1/3 times pi times 4 squared times 13. Type that all in, and you get 218 cubic millimeters. Awesome. Pretty straightforward. Okay, now we have to work a little bit backwards. Example 4, determining an unknown measurement. So a cone has a height of 8 meters and a volume of 300 cubic meters. Determine the radius of the base of the cone to the nearest meter. Okay, so if we start with the formula, volume is 1/3 pi r squared h. So now I'm looking for the radius. Okay, so we have a little bit more work to do. So look, the volume is 300, so we might as well substitute that in. So 1/3 pi r squared, and then h we know is 8. Okay, great. So now let's figure out what we can do here. Now, I like to take formulas like this, especially with fractions, step by step. So look, I'm going to take that, see how that 3 is on the bottom of the fraction? So I'm going to multiply that up. So 3 times 300, so we get 900 equals, okay, and then there's still a 1 there. So 1 pi r squared times 8. Now, I really don't need that one, so I'll scribble them off. Okay, so that's good. Now, what is the pi doing to the r squared? Well, it's timesing, so the opposite of times is divide. So divide by pi, divide by pi. So 900 divided by pi, so on our calculators, 900 divided by pi. So that works out to 286.47, so about 286. So that equals r squared times 8. So what is the 8 doing to the r squared? Well, it's timesing, so the opposite of times is divide. So I take my 286. Remember, we use all the digits on our calculators. So we go divide by 8. Okay, so then I get r squared equals 35.8. Remember, I used all my digits, so that's how I got that. Then we square root, so r equals, so the square root, and either use your ANS button or scroll up, depending on which calculator you have. Just make sure you use all your digits, and that works out to, so the nearest meter, it's 5.98, which of course works out to 6 meters. Now, there are questions out, like you have to read the question carefully, because there are questions that instead of asking for the radius, ask for the diameter. And you would figure out the question the same way. You would just have that one step at the end. If the radius is 6, well, then you'd times that by 2 to have a diameter of 12. So the diameter would be 12 meters. Now it doesn't ask for that, but I'm just giving you a heads up that it could, and you just have to make sure that you answer the question that's being asked. Okay, so we're done this part. So I need you to practice. This is section 1.5 in your textbook. Okay, you can print off the workspace page. Okay, and then you can write all over the things. It is helpful with the pyramids and everything, but again, it's up to you. It starts on page 42 in your textbook. Remember, the answers are in the back so that you can check your work, so that's always allowed. Okay, and make sure you show your teacher what you've done so that you can, or they can keep tabs on your progress. So good luck, and I'll see you next part.